Continuing our discussion of conversions, we did a lot of work just recently about how to report a number with the right number of significant figures. So that has a lot of information about the instrument that was used to make that measurement. And we don't want to lose that information if we convert the number we measure into a different unit. So we have some rules for reporting significant figures after you have taken a measurement and used it in a calculation. And these apply for any sort of mathematical manipulation you can do. We're going to focus on just two types, the most common types. And really the most common one is multiplication and division. So we'll start there. First, kind of my side note, or it's not even really a side note, I guess it's an important note. The numbers in the conversion factor, so like 1 gram equals 1,000 milligrams, because they are a definition, and that equality defines what a gram is in terms of milligrams, we don't consider them as having significant figures. Significant figures are just for measured values, things that we aren't certain about. We're defining 1 gram as 1,000 milligrams. We are certain about that. And so it has infinite significant figures, or it has 0 significant figures, depending on if you're like a glass half full or glass half empty person. So looking at multiplication and division, whenever we perform something where we're multiplying a number we measure or dividing it, we're going to make sure that we report the significant figures in the new number, so that they are the same number of significant figures as the one in the calculation that was measured that had the least significant figures. That's a mouthful. Let's look at it through 2 examples because that feels a little bit less like a mouthful. So in our example that we were doing in the previous lecture, we measured, this was 0.031 grams. Then we multiplied it by 1,000 milligrams and divided by 1 gram. This was our conversion factor. So this 0.031 grams is our only measured value, and it has 2 significant figures. So we are going to report 2 significant figures in our answer. Okay, so we had just 1 measured value in that example, so it's a little simple, straightforward. We don't have to worry about this, which one has the fewest sig figs. So let's look at a harder one with density. So density is equal to mass divided by volume. So let's say I have an object and I measure its mass and I measure its volume. So I have 2 measured values. So we have 1 and 2 measured values. Then I am going to get a huge string of numbers when I calculate what the density is by dividing 33.490 divided by 35.1 in my calculator. And I'm like, well, that's a lot of numbers in my calculator. And that's because your calculator will just keep going. I need to figure out how many to actually report to keep the important information about how these values are measured. So looking at the mass, I have 1, 2, 3, 4. I have 5 significant figures. And looking at the volume that was measured, I have 3 significant figures. So this 3 significant figures, this is our least. When we compare the volume, the measured volume to the measured mass, right? So 5 significant figures is more significant figures than 3 significant figures. So that means I'm going to report my number to be 3 significant figures. So of that big long thing that came out of my calculator, it's really the 0.954 that is significant. So I'll just report 0.954 grams per milliliter. That's the calculated density. So another one that comes up every now and then is addition and subtraction. And this is typically when we're doing conversions in between temperatures, or if we're taking averages of multiple measurements of the same thing. So in the case of addition and subtraction, we're actually going to report the number of decimal places for the measured value that had the least decimal places. And so we're really replacing this idea of tracking the least significant figures with the least number of decimal places. And so because this comes up less often, it's really easy to forget about it. And it's really just something to worry about for temperature changes for this class. So let's look at an example. Let's do a conversion from Celsius into Kelvin. We measure 40.13 degrees Celsius. So to report that value in Kelvin, we need to add 273. So in this case, that 273 is a conversion factor. So we don't worry about the number of significant figures it has, but this 40.13 degrees Celsius, that's measured. And it has 4 sig figs, and it has 2 decimal places. And for this one, because it's addition, that 2 decimal places is what's going to be important for reporting our final value. So I plug this into my calculator and I get a value, and I'm going to make sure that when I report it, I have the same number of decimal places that I have in my measured value. And so that's going to be 2 in this case. So here I have 2 decimal places. And if I look, I really have 5 sig figs. So I've actually changed the number of significant figures I have converting into Kelvin, but I have kept the same number of decimal places. And so in this case with addition and subtraction, this is actually keeping the amount of information about how precise the instrument was for measuring temperature, better than if we had gone by reporting only 4 significant figures. We would have lost information.